Hello and welcome to Chemistry 106 Lab 3, Chemical and Physical Properties. When we are looking at chemicals and chemical substances, we're interested in some of their properties. Properties are divided into one of two categories. The chemical properties, which are their behaviors and their reactions, and their physical properties, which are their traits, characteristics, arrangement, or appearance. Okay. So some of the physical aspects that we're interested in are things like their state of matter, their density, their color, their luster, their shape, the way they form a crystal, because these are all things in which they can be physically differentiated from one another if you know enough of the physical properties of a substance. And the chemical properties are important because the chemical properties and the behaviors determine their utility and their interaction with their environment. And because chemistry is the science of interaction and reaction, we are particularly concerned with whether or not they have the correct chemical properties in order for us to achieve the goals that we set out to do when we set up a chemical reaction or we're studying a chemical process. Most physical properties can be observed without change to the substance, but chemical properties usually require us to change them in some way. So physical properties are something that we always look at under the term of observation. Observation is different from explanation. An observation is simply what you notice, not an explanation for why it is so. So for example, if this were my object in question, my observations would be its length, the color of the liquid inside, the capacity of the thermometer, maybe the manufacturer, things like that. Not whether or not it's a good tool or a functional one, but what the facets and traits are of the tool that make it a thermometer. Chemical properties, however, require us to make changes to them or to observe changes. And so some of the tools that we have in chemistry, like a thermometer, are used to observe these chemical changes. Sometimes the chemical change cannot be easily seen. So what we do when we set up laboratory experiments for students is we establish reactions based on whether or not the reactions will create a chemical change that can be observed. Okay? So these include, but are not limited to, the exercises you'll be doing today. So exercise 1, exercise part A, is reactions of sodium bicarbonate or baking soda. And if you've ever done a science fair project or something like that, you may have worked with baking soda before. It's the standard cliched science fair project volcano, where someone fills the volcano with baking soda and then pours vinegar in the top, and the reaction between the vinegar and the baking soda causes both a chemical and a physical change to occur in terms of that causes the eruption to happen in the report. So when we're looking at sodium bicarbonate, what we want to do first is look at its physical properties. So again, describing its shape, its color, its luster, its behavior, its arrangement, things of that nature. And then we'll be looking at its chemical behavior, or in other words, what things can I mix with sodium bicarbonate in order to have it change chemically. Now typically chemical changes come with or are coupled to physical changes. And we'll see some of those in lab today, where because a chemical reaction has occurred, it is easy to observe because there's a physical change in the state. Okay? That one you will be doing on your own and submitting to your lab professor. In part B, we'll be looking at the reactions of sodium metal and sodium chloride. Okay? Now, even though there's sodium in both of these, they're physical characteristics, and their chemical behaviors are quite varied. Sodium is known as one of the alkali metals. It is one of the most reactive pure substances on the planet. And that is one of the reasons why you're not doing that one at home, because you don't have the safety procedures and materials in place in order to properly protect you from the consequences of that reaction. So even if you were on campus, the instructor would be demonstrating that for you. Okay? So what you will do is you will again look at the physical properties. Can you differentiate between the two, even though they both have sodium in them? Are their physical properties different? Then we'll be looking at their chemical reactivity. So both of these we'll be putting into water and observing any physical changes to the way they look, as well as chemical changes to the way they behave. Then we will record that and make notes of whether or not they are different. In part C of today's laboratory experiment, we'll be looking at what we call solution reactions. This is a variation of what we call replacement, where adding certain chemicals together causes them to exchange partners, sort of like at a dance, where because they have chemical properties, they will actually swap, and both a physical and a chemical change will be observed. In this case, we'll be looking at two substances, sodium chloride and potassium iodide. Okay. First, that's the first experiment. We'll be mixing sodium chloride and potassium iodide, measuring whether or not a reaction occurs. Now again, if you see a physical change, it typically indicates that a chemical change has occurred. But if you see a chemical change, then it is almost always associated with a concurrent physical change. So what are the physical and was there a physical change, was there a chemical change? Then you will repeat that by mixing a solution of sodium carbonate with one of calcium chloride and observing whether or not there are any physical and chemical changes. Again, these changes indicate that there's something about the behavior that has caused them to rearrange, react, and do more than simply interact. Because sometimes things will interact and you will not be able to observe any changes, and that is because they are similar enough in structure and characteristics in their chemical nature so that they will not interact with each other enough in order to cause a chemical reaction. Finally, we'll be looking at flammability. Another reason why science is best done in the proper scientific environment. We'll be looking at two different chemical reactions that result in a chemical change and a physical change. So in the first one, you will be putting magnesium metal into hydrochloric acid. Okay? This reaction will result in the evolution of a gas. And what we'll be looking at is using a flame test. Can we detect the gas once it passes through the flame? Is the gas flammable? If the gas is flammable, we will see a secondary physical and chemical change. We might not see the chemical change because depending on what the result of the combustion is, it may not be visible, but we will be able to notice it because there will be a physical change associated with it that is unique. The second one, we will combine sodium bicarbonate with HCl, and that will also cause a physical and chemical change. In this case, it will release hydrogen gas. In this case, it will release carbon dioxide gas. And then we'll see what happens to the flame as the gas is evolved from the test tube, and whether or not we can measure a physical and chemical change. Now in both of these, there is both a physical and chemical change caused by the gas evolved. They are different changes, and they are different in terms of what changes as a consequence of the gas moving across the flame. So make your observations of that, and then you'll be asked in your laboratory report to make explanations about what you observed in lab. So again, remember to do the part that you turn in. Be safe as always. Thank you, and good luck on your lab reports. Hi, this is part B of the experiment for this week. This is reactions of and in water. So the first one we're going to do here is we're going to take some ordinary table salt, sodium chloride, and we're going to put it in this beaker here. we are going to look at whether or not it reacts or interacts with the water. And while we let that sit a bit, we'll set up the next one. The next one we're going to look at this sodium metal here, and this is what sodium metal looks like. Oops, it's going in focus. That's our sodium metal. Our sodium metal here. Okay, and we're going to see what reactions it engages in when we put it into water. So note any physical and chemical changes to the sodium once it is interacting with the water. Record your observations and explanations. Meanwhile, in front of us, we still have our salt in our water. Today's sodium was relatively mild, which is good. Okay. So now note in the beaker that we have here, has the sodium chloride reacted with the water or interacted with the water. So also you can see this little tiny bit of sodium still skating around on top of the water. If the room was dark enough, you'd also be able to see a color. I think sodium is yellow. And it's done. Okay. All right. From there, we're going to go to this final bit of observation here. What we have here is a solution of saturated sodium chloride. So I've put this saturated sodium chloride solution into this beaker, and I have another one here that I have boiled down nearly to dryness. And what we're going to look at is then the reverse reaction, the reverse interaction of when you put sodium chloride into water and then you remove the water from the solution. So we're going to wait for that to boil and then we'll remove it and make our observations. Okay, we have this at a rapid boil now, so it shouldn't be too long before the water is all driven off, leaving behind only the sodium chloride. And try and remove it before the salt jumps out, because it's going to try to jump out at the end when the water's all gone. So I want to make sure when you're doing this that you're using the proper tools and safety precautions. Just before all the water is gone, but not let the water all evaporate out, or we run the risk of breaking the beaker. But you can see water's jumping out, salt's jumping out. Look in here now, you can see the crystallized, just a little bit of water in there, but you can see the crystallized sodium chloride on the side. Of the beaker, and you can see the crystals that have formed once we've driven off the water. All right, in part C of the lab, we're looking at solution chemistry. What we have here is a beaker with some sodium chloride already added to it. We're going to add some of this potassium iodide. Measure the chemical and physical changes that we observe. Okay, while we let that sit, over here in this second set, we have a beaker with some sodium carbonate, and then we're going to add some calcium chloride and measure the physical and chemical changes that we observe. Okay, so this is calcium carbonate, sodium carbonate, and calcium chloride. We go back over here to our sodium chloride and potassium iodide. Okay. In part D, we're looking at flammability of compounds that have reacted. So in these two test tubes, we are going to put these small pieces of magnesium metal. A small thin strip into each of the test tubes. Then we're going to add just a little bit of this half molar hydrochloric acid. Then we will strike the match and measure whether or not the gas that has evolved from this reaction is flammable. Turn this here, so they're here in the front. Do one at a time with the matches. So you can see there is a reaction occurring here, physical and chemical changes occurring. What I'm trying to do here is trap some of the gas so there's enough of it for you to see the reaction that you're supposed to see. that was the reaction you're supposed to see. Alright, let's try this one again. At least it worked once. Okay, for the second one we have 2 tubes of sodium bicarbonate or baking soda, and we're going to do the same thing to them. We're going to add some hydrochloric acid. Put a little bit more in there because, so you can see there's a chemical and physical reaction taking place. Now quickly, as quickly as these matches will allow, try these Eisenhower matches instead. Be better. These are the light. Okay. That is, believe it or not, the reaction you're supposed to see. Do it one more time with this particular tube. I think it's almost out of gas, but okay. Now we'll do the second tube here. I'll get 2 matches ready. Okay, so again, sodium bicarbonate. And that concludes the laboratory exercises portion of this particular week's activity.